Hey, welcome to the 18th session of the Flipped Classroom for AP Calculus. Today we're going to talk about derivative of inverse trigonometric functions. What fun! First of all, recall that two functions that are inverses of one another have their ordered pairs, that is, x and y, just switched. So you're switching the y with the x. The range of one function, in other words, whatever y can be, becomes the domain, whatever x can be, of the second function. For example, to find the inverse of y equals 1/2 x plus 1, just solve for x and rewrite it as f negative 1, the symbol for inverse, of x equals 2x minus 2. Graphically, these two functions will be reflected across the line y equals x. Graph the two functions as y1 and y2, and then y equals x as y3. What do you notice? You should notice that they're reflected across y equals x. The derivatives of inverse functions will always be reciprocals of one another. So in our previous examples, the derivative of 1/2 x plus 1 would be 1/2, and the derivative of its inverse, 2x minus 2, would be 2. So therefore you can see the derivatives are reciprocals of one another. Derivative of sine of what's called sine negative 1 of x, or arc sine. Alright, so we start with y equals sine negative 1x. That is the same thing as saying x equals sine of y, because you're switching. In the original function, you would just switch the x and the y. So let's just take the derivative of both sides of x equals sine of y with respect to x. You would get 1 equals the cosine of y. Don't forget, you have to multiply by y prime. So y prime would be 1 over cosine of y. Remember the old trigonometric identity, sine squared of y plus cosine squared of y equals 1. Solving that identity for cosine of y, I get cosine of y equals the square root of 1 minus sine squared of y. Okay? So therefore, y prime, which is 1 over cosine of y, would be 1 over the square root of 1 minus sine squared of y. But we originally stated that the sine of y equals x, so I can substitute x in for sine of y, and I get y prime equals 1 minus 1 over the square root of 1 minus x squared. Now, if there was a composite function u of x, okay, where u is some composite of x, then that derivative of arc sine of u would simply be u prime, the derivative of the inside function, all over the square root of 1 minus u squared. Okay, in the next slide we're going to discuss the derivative of arc cosine of x. Same procedure. If y equals arc cosine of x, that is the same thing as x equals the cosine of y. Take the derivative of both sides. 1 would equal negative sine of y times y prime. Y prime would equal negative 1 over sine of y. Sine of y, using our trigonometric identity of sine squared plus cosine squared equals 1, would equal square root of 1 minus cosine squared of y. But remember, the cosine of y was equal to x. So substituting that in, I get y prime equals negative 1 over the square root of 1 minus x squared. Exactly the same as the derivative for arc sine, except it's negative. If there is a composite function u of x, then the derivative of the arc cosine of u with respect to x is simply negative u prime, derivative of the inside function, over 1 minus u squared, square root of 1 minus u squared, I'm sorry. How about tangent? Well, y equals arctangent of x. That's the same as x equals the tangent of y. Okay, take the derivative of both sides with respect to x. I get 1 equals secant squared of y times y prime. Solve for y prime. Y prime is 1 over secant squared of y. But remember our identity, sine squared of y plus cosine squared of y equals 1. But now what I'm going to do with that identity, I'm going to divide both sides I'm going to divide both sides of that identity by the cosine squared of y. Okay, and I come up with a new identity. I get tangent squared of y plus 1 equals 1 over cosine squared, which is the same thing as secant squared of y. Okay, so now y prime again equals 1 over secant squared of y. That is the same thing as 1 over 1 plus tangent squared of y using my new identity. But remember in the beginning we said tangent of y was x, so that would be the same thing as 1 over 1 plus x squared. If u is a composite of x, I got to multiply by the derivative of the outside times the derivative of the inside. Okay? Well, the derivative of the outside is just going to be 1 over 1 plus u squared. Multiplying by u prime, I would get the derivative of arctan of u would be u prime all over 1 plus u squared. We're going to do some sample problem here in a minute. One more. The derivative of secant, arcsecant of u, is u prime on the top all over the absolute value of u times the square root of u squared minus 1. Okay? Here's a sample problem. Let's say that y equals the arcsine of 3 over t squared. First thing I do is I rewrite it as y equals arcsine of 3t to the negative 2. I let u be 3t to the negative 2. Therefore, du dt, or u prime, would be negative 6 t to the negative 3. By the formula, the derivative of sine of u, arcsine of u, with respect to t, would be equal to u prime, that's negative 6 t to the negative 3, all over root 1 minus the quantity negative 3 t to the negative 2, that's u squared. Simplifying that, I get negative 6 t to the negative 3 all over root 1 minus 9 t to the negative 4th. That would be the derivative of arcsine of 3 over t squared. For practice, I would like you to work on page 221, 222, numbers 1 through 18, and numbers 31 through 34. We can work on those in class tomorrow. And if you have any questions, I can help you. Have a good night.